Question number 7. Angle of the prism is 30 degrees and its refractive index is √2 and one of the surfaces is silvered. At what angle of incidence a ray of light should be incident on one surface so that after reflection from silvered surface, it retraces the path? It is a repeated question. It's a previous ITJ question as well. Okay, so you are silvering one surface of a prism. Silvering means what? You are trying to make it a mirror. Let's draw the figure now. Draw the figure. This is the prism, okay? This is the prism. And you are coating one side with the silver. That is how you make mirrors, right? Right. You will coat one side of the surface, one side of the prism with mirror. Okay. You can't do the first surface because light has to get in, right? All right. So the second surface of the prism, as per the question, is silvered, is coated with the silver. Let's go on reading. What else is given in the question? Angle of the prism is 30 degrees. Angle of the prism is 30 degrees. And then refractive index is also given. It is equal to √2. Okay, at what angle of incidence a ray should be incident on one surface? They have to find the angle of incidence on the first surface, right? So that it retraces the path. What is meant by retracing? Retracing means it's going back along the path through which it came. All right. So the ray retraces the path on a mirror when? You learned this in class 10. If a ray falls normally on a mirror, that will retrace the path. For normal incidence, the ray will retrace the path. Okay. The ray retraces the path when it falls normally on a surface. So look at that. I'll just illustrate the situation now. So this is how the ray would come in. The ray would come in. It falls on the surface normally. Then only it can retrace the path. Look at that. It is falling normally on the surface. See the ray? It is going in. It falls on the mirror. And then it retraces the path like this. Do you understand? Then what? I can draw the normal here. This is where I draw the normal. All right. And I can complete the incident ray this way. This is the incident ray. Look at that. Now, it looks like an incident ray has just gone in. It went from rarer medium to denser medium. So it is bending towards the normal, right? So that actually completes the picture. Okay. So we got this angle as 90 degrees, right? Because it is normal incidence, I said. Normal incidence means it's falling perpendicularly, right? Normal incidence. So that is 90 degrees. This is 30. 90 plus 30, 120. That makes this angle 60 degrees, right? If that is 60 degrees, how about the next angle? This angle must be equal to 30 degrees because this is normal I have drawn, which is in fact making 90 degrees, right? This is normal. That is normal I have drawn. It is making an angle of 90 degrees. Look at that. It's making an angle of 90 degrees. Look at that. It's making 90 degrees there, okay? So one of the angles is 60 means the other angle has to be 30. And I call this angle by the name angle of incidence, I. Okay. Now, let us apply Snell's law for this surface. How to apply Snell's law? You must write n is equal to sine by sine. We always find refractive index of denser medium with respect to rarer medium. In that case, angle inside denser medium should come on denominator. Denser medium angle on denominator. Rarer medium angle on numerator. So, denser medium angle is 30. Rarer medium angle is I. That should be on numerator. So, I can cross multiply. So, sine I will be equal to what? Cross multiply. N into sine 30. And that gives me n is equal to √2. Sine 30 is 1 by 2. Cutting them, I get 1 by √2. √2 and 2 are cut. You're getting 1 by √2. Sin I is equal to 1 by √2 means I should be equal to 45 degrees. So angle of incidence is equal to 45 degrees. Answer is option C. All of you got it?